Good morning student. Previous class I discussed about some rules regarding about the nomenclature of organic compound containing functional group. Now I am going to discuss some other rules regarding about the nomenclature of organic compound containing functional group. Take another example: CH3 bond CH bond OH bond CH2 bond CH2. In this example, there are two types of functional group are present. One is bond OH, another is your bond CHO. For naming such type of organic compound, we generally follow the seniority table. According to the rule, the functional group which is present in the top of the seniority table are generally used for suffix and the other is used for prefix. That means in the naming of this organic compound, bond CHO is used for suffix, on the other hand bond OH is used for prefix, because bond CHO is present in the top of the seniority table and bond OH present below the bond CHO functional group. Look at that, this is the seniority table. In the seniority table, different functional groups are present. It is bound to remember the order of different functional groups arranged in the seniority table. It is also bound to remember the prefix and suffix of the functional group. Our aim to give a name to this organic compound. For naming such type of organic compound, we generally follow a rule. The rule is when an organic compound contains two or more different functional groups, one functional group is regarded as the principal functional group and other functional group is treated as the secondary functional group or substituent. Look at that, in this organic compound, two functional groups are present. One is your bond OH, another is your CHO. In the seniority table, bond CHO is present above the bond OH. So, according to this rule, bond CHO is used as the principal functional group and bond OH is used as secondary functional group. So, according to the rule, it is bound to use the suffix of bond CHO. On the other hand, it is bound to use the prefix of bond OH for the naming of this organic compound. Always remember an important point. For the naming of such type of organic compound, we generally use the suffix of principal functional group and we generally use the prefix of secondary functional group. For naming such type of organic compound, we generally use the suffix of CHO because your CHO is the principal functional group. On the other hand, it is bound to use the prefix of bond OH because bond OH is the secondary functional group. Remember also an important point, the selection of longest continuous carbon chain and the numbering of the parent chain must be done accordingly the principal functional group. That means all the priority given to the principal functional group. So according to the rules, this is the parent chain and it is bound to start the numbering like this 1, 2, 3, 4. In the third number carbon the bond OH is present, so it is bound to write the name of this organic compound 3 hydroxy butanol, or you can also write 3 hydroxy butan 1Al. Similarly, take another example, CH3, bond CH, bond OH, bond CH2, bond CH2, bond COH. In this organic compound also two different types of functional group are present. One is your bond OH, another is your bond COH. Look at that, your bond COH is present, your bond OH is present. From this table it is clear that bond COH is present above the bond OH. So according to the rule, bond COH is used as principal functional group. On the other hand, bond OH is used as a secondary functional group. From this rule and the scenario table, it is concluded that for the naming of such type of organic compound, we generally use the suffix of bond COH and it is bound to use the prefix of bond OH. And the selection of the parent chain and numbering of the parent chain must be done accordingly bond COH group. So the parent chain is this, and I can start the numbering like this: 1, 2, 3, 4, 5. The name of this organic compound is 4-hydroxy pentan 1-oic acid. We can also give a name 4-hydroxy pentanoic acid. Suppose an organic compound is given, that is your 3-methyl butanoic acid. Tell me what will be the structure of this organic compound. Your but is the word root, N is the 1 degree suffix, oic acid is the 2 degree suffix, and this part is said to be 1 degree prefix. From the word root I can write 4 carbon like this. Look at that, here the 1 degree suffix is present, that is your ANE, that means it is bound to give single bond like this. Here the 2 degree suffix is present, that is your oic acid is present, that means we generally use oic acid for bonds COH. So it is bound to give one position to the bond COH group. So suppose this is your 1 number carbon, then it is bound to write your bond COH. This is your 1, this is your 2, this is your 3, this is your 4. Look at that. In the name of the organic compound 3-methyl is given, that means a methyl group attached to the 3 number carbon atom like this. Now satisfy the tetracovalence of each carbon atom. That's why I can write here S3, here I can write H, here I can write H2. The structure of this organic compound is this. Suppose take another organic compound but 2En1Al. Look at that, your word root is but. This is your 1 degree suffix. This is your 2 degree suffix. From the word root I can write 4 carbon atom like this. From the 1 degree suffix it is bound to give a double bond in between the 2 number carbon and 3 number carbon atom. Suppose this is your 1 number carbon, this is your 2, this is your 3, this is your 4. Then it is bound to write your CHO because Al is present as a 2 degree suffix. Next it is bound to give single bond here, then it is bound to give single bond here. Now satisfy the tetracovalency. For maintaining the tetracovalence of carbon atom, it is bound to write your hydrogen. You are also bound to write hydrogen. It is bound to write your S3. The structure of this organic compound is this. This is all about the rules for nomenclature of organic compound. Next, I am going to discuss about Isomerism. It is an important topic. The word isomerism derived from two words. Number one is isos. Number two is meros. Isos means equal. Meros means part. That means equal part. What is the meaning of isomerism? The compound having same molecular formula, but differing in physical and chemical properties are called isomers. It is also called isomerites, and the phenomenon is called isomerism. There are two types of isomerism, such as number one is structural isomerism, number two is stereo isomerism. At first, I want to discuss about the structural isomerism. What is the meaning of structural isomerism and what are the types of structural isomerism? The isomerism due to the arrangement of atoms within the molecule, resulting in the several structural formulae, is called structural isomerism, and the compounds exhibiting the structural isomerism are called structural isomers. There are different types of structural isomerism. Number one is chain isomerism. Number two is positional isomerism. Number three is functional isomerism. Number fourth is metamerism. Number fifth is Torto Medium. Next, I want to explain about the chain isomerism. What is a chain isomerism? The isomerism arises due to the difference in the structure of the carbon chain, which forms the nucleus of the molecule, is called chain isomerism, and the compounds exhibiting in the chain isomerism is called chain isomer. Let me explain the chain isomerism with example. Suppose I want to take an example: CH3, CH2, CH2, CH3. This is your said to be N-butane. Here N is said to be normal. What is the chain isomer of N-butane? This can be drawn by the help of decreasing or increasing in the number of carbon atoms present in the parent chain. In this organic compound, there are 4 carbon atoms present in the parent chain. So, in this case, I cannot increase the number of carbon atoms in the parent chain. This organic compound having molecular formula C4H10 I want to draw a chain isomer of this organic compound. For this organic compound, I can decrease the number of carbon atom in the parent chain. Here 4 carbon atoms are present, so I can decrease the number of carbon atom. That means from 4 to 3. So here I can write CH3 bond CH bond CH3. Suppose the 4th carbon will attach here. Look at that, here the parent chain is this. In this parent chain there are 3 carbon atoms are present. So if I will compare to this organic compound, they are having same molecular formula but they are different in the structure of the carbon chain. The name of this organic compound is 2-methyl propane. Look at that, here 4 carbon atoms are present, here 3 carbon atoms are present in the parent chain. Suppose I want to draw an organic compound in which 2 carbon atoms are present in the parent chain. This cannot be possible. Look at that. If I want to draw like this, these are the 2 carbon atom present in the parent chain. Suppose I will attach here 1 carbon atom. Here also I can attach 1 carbon atom. Here I can give bond CH3. Look at that. Now this will be the parent chain. I want to draw an organic compound in which 2 carbon atom present in the parent chain, but this cannot be possible. This organic compound is same with this organic compound. So this type of organic compound does not consider in the list of chain isomer of this organic compound. By this way we can able to draw different type of chain isomer of an organic compound. Remember, it is bound to change the structure of the carbon chain. Here the structure of carbon chain is this. Here the structure of carbon chain is this. Look at that. These two structure of carbon chain of these two compounds are different from each other. So both two compounds are said to be chain isomer of each other. Suppose I will take another example. CH3 bond CH bond CH3 bond CH2 bond CH3. What are the chain isomer of this organic compound? Look at that, here 5 carbon atoms are present in this organic compound but only 4 carbon atoms present in the parent chain. The name of this organic compound is 2-methyl butane. I want to draw the different chain isomer of this organic compound. This can be possible by changing the structure of the carbon chain. The structure of the carbon chain can be changed by changing the number of carbon atoms present in the parent chain. Look at that, totally have 5 carbon atoms present in this organic compound. So I can draw an organic compound which is having maximum 5 number of carbon atoms in the parent chain. In this case, I can decrease the number of carbon atom in the parent chain and also increase the number of carbon atom present in the parent chain. Suppose I want to draw an organic compound which having 5 number of carbon atom present in the parent chain, then I can draw the structure like this: CH3, CH2, 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 CH3. Look at that, this compound having formula C5H12. This organic compound also having molecular formula C5H12. Here the structure of carbon chain is this. Next I want to draw another organic compound by decreasing the number of carbon atoms present in the parent chain. Suppose I want to draw an organic compound which having 3 number of carbon atoms present in the parent chain, then the compound can be written like this: CH3 bond C bond CH3 bond CH3 bond CH3. Look at that. The formula of this organic compound is C5H12. The name of this organic compound is 2,2 dimethyl propane. This is the parent chain. Look at that. The structure of this carbon chain is different from this and also from this. Suppose I want to draw an organic compound in which two carbon atoms present in the parent chain. I can draw the organic compound like this. Suppose I will try. Look at that. Suppose take two carbon atoms like this. There are 5 carbon atoms present in the organic compound. It is bound to give your CH3, also your CH3, also your CH3. Here I can write also CH3. I want to do an organic compound which having two carbon atoms present in the parent chain, but this cannot be possible. Look at that. This organic compound is similar with this organic compound. So I cannot consider about this organic compound in the list of chain isomerism of this organic compound. From this it is clear that this organic compound having 3 chain isomer and they are chain isomer to each other. Number 1 is your this, number 2 is your this, number 3 is your this. These 3 are said to be chain isomer of each other. Next I want to explain about the position isomerism. What is the position isomerism? The isomerism arises due to the difference in position of the same functional group or substituent in the same carbon chain is called position isomerism, and the compound exhibiting the position isomerism is called position isomer. Let me explain the position isomerism by the help of example. Suppose take an example. CH3, CH2, CH2, Cl. The name of this organic compound is said to be 1-chloropropane. Here chlorine is the substituent and it is present at the 1 number carbon atom of the parent chain. This is your parent chain. Now I want to draw the position isomer of this organic compound. This can be possible by changing the position of this substituent. Now I can draw an organic compound in which the chlorine atom present at the 2 number carbon atom. So I can write the compound like this: CH3 bond CH bond Cl bond CH3. The name of this organic compound is said to be 2-chloropropane. Look at that. Here the position of the substituent changes. Here the position of the substituent is 1. Here the position of the substituent is 2. That means these two compounds having same molecular formula, but they are different in the position of the substituent. So these two compounds are said to be chain isomer of each other. Take another example. This is your example 1. I can take the example number 2. CH2 double bond CH bond CH2 bond CH3. The name of this organic compound is but1N. Here the position of double bond is 1. This double bond present in between 1 number carbon atom and 2 number carbon atom of the parent chain. This is your 1 number, this is your 2, this is your 3, this is your 4. Now I want to draw the position isomer of this organic compound by changing the position of the double bond. I can write the organic compound like this: CH3 bond CH double bond CH bond CH3. The name of this organic compound is your but to Ene. Look at that, here the position of double bond is changed. Suppose I want to change this double bond from this carbon to this carbon, then I can write the structure like this: CH3 bond CH2 bond CH double bond CH2. The name of this organic compound is said to be also but1Ene. Look at that, this compound is same with this compound, so I cannot take this compound into consideration. Like this, you can also change the chlorine atom from this carbon to this carbon. Then I can write the compound like this: CH2 bond Cl bond CH2 bond CH3. The name of this organic compound is also 1-chloropropane, which is also similar with this organic compound. So in this case also we cannot consider. That means this compound having two position isomer. This is your one, this is the another. This compound having also two position isomer. First is this, second is this. Remember an important point. Generally, there are two types of functional groups are present. One is your terminal functional group, another is the simple functional group. Bond CHO, bond COH, bond CONH2, bond COCl, bond Cl. These are said to be terminal functional group because this type of functional group himself carry the carbon atom, and this carbon atom is counted in the numbering of the parent chain, and they always carry the position 1 in the numbering of the parent chain. So this type of functional group do not show the positional isomerism. But if I will think about the functional group like bond OH, bond NO2, like this type of functional group does not carry any carbon atom. So this type of functional group cannot show the terminal functional group. You can change the position of this type of functional group and you can able to form different types of positional isomer of a particular organic compound. Next I will discuss about the functional isomerism. What is the functional isomerism? The isomerism arises due to the presence of different functional group is called functional isomerism, and the compound exhibiting the functional isomerism is called functional isomer. Let me explain some examples related to the functional isomerism. Example number 1: CH3 bond O bond CH3. The name of this organic compound is said to be dimethyl ether. Here ether functional group is present. This is your ether functional group. This organic compound having formula C2H6O. Next I want to draw another organic compound which having same formula but different in the functional group. I can write the compound like this: CH3 CH2OH. Look at that, this compound having also formula C2H6, but in this compound bond OH, that is your alcohol, is present as functional group. The name of this compound is said to be ethyl alcohol. Look at that, these two compounds having formula C2H6O, but they are different in the functional group. Here ether functional group is present, here bond OH functional group is present. That means these two examples having same molecular formula but they are different in the functional group. So these two compounds are said to be functional isomer. Take another example, CH3 bond C double bond CH3. The name of this organic compound is said to be acetone. Here ketone is the functional group. This is your keto functional group. The molecular formula of this organic compound is C3H6O. I can draw another organic compound. Suppose I want to draw an organic compound like this, CH3, CH2, CHO. This organic compound having formula C3H6O. The name of this organic compound is said to be propan 1L. It is simply called propanol. Look at that, here aldehyde functional group is present. From these two compounds it is clear that these two compounds having same molecular formula but they are different in the functional group. So these two compounds are said to be functional isomer of each other. Next I want to explain about the metamerism. What is the metamerism? The isomerism arises due to the unequal distribution. Due to the unequal distribution of carbon atom on either side of the same functional group. Again I will repeat, the isomerism arises due to the unequal distribution of carbon atoms on either side of the same functional group in a molecule of a compound belongs to the same class is known as metamerism, and the compound exhibiting the metamerism is called metamorphs. In this type of isomerism, generally remember an important point: same functional group, same class, but different the distribution of carbon atom on either side of the functional group. Look at that. Suppose I want to take an example: CH3, CH2, bond O, bond CH2, bond CH3. Take another example: CH3, bond O, bond CH2, bond CH2, bond CH3. In this compound, ether is the functional group. Here also, ether is the functional group. But in this case, the left side is your ethyl group, the right side is also ethyl group. But in this compound, the left side is your methyl group, the right side is your propyl group. That means in these two compounds, the distribution of the carbon atom different on either side of the functional group ether. They belongs to the same class of the organic compound. So these two compounds having different distribution of carbon atom on either side of the functional group. So these two compounds are said to be metamorphs to each other. Take another example: CH3, CH2, bond C double bond O, bond CH2, bond CH3. I can write another example: CH3, bond C double bond O, bond CH2, bond CH2, bond CH3. Look at that. In this organic compound, this is the functional group. The name of this functional group is said to be keto. In this organic compound, this is the functional group. The name of this functional group is said to be also keto. In this organic compound, the left side of this functional group, ethyl group, is present. On the right side of this functional group, also ethyl group is present. But in this case, The left side of this keto-functional group, methyl group is present. On the right side, propyl group is present. That means you have the distribution of carbon atom on either side of the same functional group in molecule of compounds belong to the same class are different. So these two compounds are said to be metamorphs of each other. If I want to write the name of this organic compound, then I can write the name of this organic compound like this: pentan 3-guanine, because here the keto group present at the 3 number carbon atom. The name of this organic compound is said to be pentan 2-guanine. Here the position of ketone is 3. Here the position of ketone is 2. So these two compounds are also said to be positional isomer of each other. So remember an important point: metamerism is a special case of positional isomerism. Next I want to explain about the Torto Medium. What is the meaning of Torto Medium? The compounds with the same molecular formula existing in dynamic equilibrium with each other are said to be tautomer, and the phenomenon is called Torto Medium. Take an example: CH3 bond C double bond O bond H. The name of this compound is said to be ethanol. Take another compound CH2 double bond CH bond OH. The name of this organic compound is said to be vinyl alcohol. Look at that. Here the functional group is aldehyde. Here the functional group is OH. Here also double bond present. If I will start the reaction and if I will take ethanol as the reactant, then it undergoes reaction, gives the vinyl alcohol. Simultaneously, when vinyl alcohol undergoes reaction, gives also ethanol. That means it is a reversible reaction. Here a dynamic equilibrium maintained in between the ethanol and vinyl alcohol. No doubt, these two compounds are said to be functional isomer to each other, but there is a relationship in between these two compounds. These two compounds are in dynamic equilibrium. So such type of isomers are called tautomers, and the phenomenon is called tautomerism. Remember an important point: tautomerism is considered as a special case of functional isomerism. Similarly, take another example: CH3 bond C double bond O bond CH3. The name of this compound is said to be acetone. Take another compound CH3 bond C bond OH double bond CH2. The name of this organic compound is said to be propene 2OL. Both these two compounds are said to be functional isomerism to each other, and also there is a relation in between these two compounds. They are dynamic in equilibrium. So these two functional isomers are said to be also tautomers. That means they have a relationship like reactant and product. This is your reactant, this is your said to be product. If this is said to be reactant, then this is said to be product. This is all about for this class. Thank you. Have a